introduce Damien. Damien came in with us. He led the chapter at Drexel University and then graduated, right? And then graduated. Right. And now he's on the board of Icarus Interstellar. And he has, in case you haven't seen his talk from 2015 at Drexel University, you need to Google Damien Turchi and watch his talk. It's one of the best things I've ever seen in the interstellar movement. And also, I have to point out that this whole sound system, all the audio-visual, everything that's going on here today is because of Damien. That is the success right here. Thank you.
Thanks, Mike. So, read this title for a second. The last 3 words, permanent lunar settlement. This has been an idea since as far back as the Apollo days. People have been discussing this, creating various designs, but why hasn't it happened yet? A lot of people say that Apollo, that was just a Cold War race, and that was due to fear of nuclear catastrophe. And then after the space race was won by the United States, that fear seemed to just go away, and the space race ended. So we haven't been there since then. So how in this current socioeconomic world that we're in will we make another attempt to get to the moon? There's a lot of talk right now, but it's decentralized. The last time NASA did a very large design review on lunar settlements was back in the early 1990s. And you're going to see how dated that is in this presentation, because when I get to it, the illustrations look nothing like the CAD models that people produce today. So why can't Icarus Interstellar be that centralizing force that works together, that works very hard, brings brilliant minds together, and creates a real, feasible, permanent lunar settlement that we can then push to agencies such as NASA, CSA, JAXA, all of the different countries that are involved in this. I was talking at dinner last night, and I was told space is for everybody doesn't just mean all the races and disabled people. It also means all of the countries have to get together too. And that's not an easy problem to solve. So this was taken by Cassini, I believe, in its final days right now, so everyone be sure to keep up with its dramatic dives through the rings in the next coming weeks. But that's Earth, circled in blue there, or circled in red, and it's the blue dot. And we all know Carl Sagan's famous monologue on the pale blue dot. So the theme of this conference is, what does the moon mean to Interstellar? Why do we all need to work together? Why do all of the countries need to get together to first get to the moon and then get to the stars? And if you look at this blue dot, that's because we're all on that. Every single one of us is on that. And look how big Saturn is in comparison in this frame of reference. So, we all have to get together, and Icarus Interstellar is going to be that centralizing force. So for this presentation, which I'm going to run through fairly quickly, I'm more excited to talk to people afterwards than come here and talk directly to everyone without any feedback. We're going to briefly talk about things that concern the moon. Not everyone here is familiar with the basic science. Then we're going to do a brief review of the 1990s report by NASA. And then we're going to talk about all of the orbiters that are currently going around the moon and what we've learned since that large report in the 90s. Then we're going to talk about suggested action, and we were supposed to have a hackathon last night to continue work on this. However, that got a little pushed out due to time constraints. So if you want to talk more about this with me, we can discuss at lunch and during the breaks. So there's a few challenges on the moon. You know, it doesn't have any atmosphere, so to speak. And also, there's some weird composition in the regolith that actually can prove useful. If you don't know the word regolith, that just means soil on the moon, all of the rocks and such. Because it doesn't have any atmosphere, there's a lot of micrometeor impacts and large meteor impacts. So when we build our base, we have to keep that in mind. And also the temperature can vary wildly from a very comfortable 200 Kelvin all the way to, I think, pretty close to absolute zero. You can correct me if I'm wrong with numbers. In the permanently shadowed regions on the poles, which are actually our favorite regions because that's where there might be ice. So I talked about regolith. There's two main words that people use when they're talking about lunar features. There's the terra, which are the highlands, and there's the maria, which are the lowlands. The poles are very interesting because of what I said, the permanently shadowed regions and the fact that we saw evidence of ice there. And lava tubes are something that seems to get neglected. They're these big kind of holes in the ground that are already covered, so we don't really have to worry about radiation protection. The regolith is actually a very good radiation protection. So, yeah, just a brief overview of some things with the moon. All right, so now I'm going to talk about the bases that have been worked out in the 1990s NASA report, and you're going to see how dated these illustrations are. You know, they didn't have fancy CAD models and super 3D structures that you can peer through that may or may not be scientifically accurate. These people did a nice, comfortable illustration to try and give you the idea while also doing the engineering work behind it. So I'm not going to go into too much detail on these, but NASA selected 3 of, I think, like a dozen or 2 dozen bases that they reviewed that they thought would be the best path forward. However, that never happened. After this report, things kind of hit a wall, and we more focused on robotic missions. Not to say that that's bad, but we did stop there when it came to human habitats. So this was a very interesting design. This is inside of the moon. Here is the lunar regolith, and you also had a section at the top where there would be telescopic arrays that Tiffany was talking about, how you can do good scientific experiments on the moon due to the vacuum, and also due to the lack of atmosphere. You can really look out there. So up here you would have not only rockets taking off and mining occurring, but you would also have those kind of scientific experiments, such as the telescope arrays. And then people would live underground where they're already protected from radiation by the regolith. Here's another design, a little hard to make out still because we're dated. We're in the 1990s when this illustration was made. But this is a large pneumatic tube that's inflated and then put up to 1 atmosphere, and it's held down by certain trusses that all of the architecture was worked out for that. So we do need architects, Aaron, to help out with this. Here's another design, and this was basically a large inflatable bubble, and half of it would be underground and secured in the regolith, and the other half would be outside of it, and there would be multiple floors in it, and I was surprised that this made the final cut, honestly, just looking at the illustration. But when we work together to solve this problem, we should be reading into the details of the engineering details of this design, which I have not done yet. That's what I'm relying on all of the geniuses out here to help with. So a part that I'm more excited to quickly discuss is the various missions that have been to the moon since these designs in the 90s and how much we have learned. Clementine went up in 1994, almost immediately after this design review, and that was one of the first orbiters to actually observe the poles and detect presence of hydrogen, not water. But a lot of people were stretching out there and saying it was water. We didn't actually know it was water until L-Cross impacted the moon in the end of the first decade of the 2000s. So we had Clementine, we had Lunar Prospector, all of these great designs that if you want to know more about these orbiters, you can ask me later. I'm not going to drag on about it because we do have time constraints. But one of the ones that has open source data that, oh wow, that I think we should really talk about and look up the data on and study as an organization is the LRO. The Lunar Reconnaissance Orbiter is still in orbit around the moon, collecting multispectral data and making a lot of collections that are very important to a feasible engineering design of a lunar base. Here's some future missions, which I'm already down to 5 minutes, which is fine. But so I'm going to skip through this, and if you want to talk about this later, we can. One thing I want to point out are these missions here, though. Lunar Flashlight, Lunar Ice Cube. These are all CubeSat missions. Very low-cost missions that collect useful data. And that could be something we talk about if we want to collect our own information. Perhaps we could build a CubeSat. So the whole point of this, I very quickly went over a few designs and over orbiters, is because I think as a group together, we should work on making a lunar base that works in the socioeconomic standards of today. And I'm going to call it Project MAPS, Moon as a Pathway to the Stars. So there are two goals from Project MAPS, permanence and significance, and these both align with Icarus Interstellar's goals. With permanence, we need to start off somewhere that we can afford to do today, but make the design such that we can build up to including everybody there, making a living habitat. And also significance. We need to have real scientific products from this lunar base and be able to help us build a Starship one day by having a lower escape velocity and being able to create our own rocket fuel using some of the frozen water on the planet. So I apologize for very wordy slides here, and if you want to see this later, you can also ask me, but there's two parts to this that I think we can do in the very near-term future. Citizen scientists, so all of you are able to help achieve this goal by providing peer-reviewed journals. You know, you don't have to be scared of this word. We can work together to find workable abstracts and create a design plan to develop an actual scientific report. It's a lot easier than you might think. It's not something to be scared of. And also, we have a lot of student chapters, and that was my goal at 2015, was to really encourage the idea that we need to get the next generation interested in this. So a few of our chapters have actually mentioned that they're interested in working towards this goal of creating a lunar settlement. So we're going to do senior design projects for undergraduates and perhaps theses for graduate students. And then after we have a bunch of student design projects and peer-reviewed journals, we can culminate our findings in a design report of what Icarus Interstellar's idea of a permanent lunar base is. And during this presentation, I did not give you any ideas for a base. That's the challenge. We have to figure out how to work together to come up with something. And we've heard brilliant ideas yesterday, and we should continue to move those into actual fruition. So this is just a very rough schedule, but I wanted to have some action items. And the goal was by the end of this month, we will have a team together. So if you're interested in being part of this team, let me know, and we will generate a team and some hierarchy for that team. We also should try to get a few studies out by the end of this year. And it's really not a hard goal, I think, to achieve 5 if let's say, 10 of you are interested in participating. 2 student design projects by the end of next academic year, and I already got 1 in the works, so that's very possible. And then a few other more extended goals, and the super goal is by Starship Congress 2019, we will have a final report on our findings and then move forward from there. So these were the ideas of a hackathon. We would develop basic scientific questions and abstracts that we could answer, but we're not going to have that, so we can talk at lunch. So come to me and let's talk. Here's some references. And I did have a video, but I accidentally updated it as a PDF. And this video was a song about getting everyone inspired to participate in the moon, and it was developed by Goddard Space Flight Center. So I'll try and bring that up later. So thanks, everyone. That's my presentation. If you have questions for me, we'll talk later. Thank you.
Okay. Are there any questions for Damien? I'm going to. A good thing has happened to me. It's coffee. It's amazing.
Hi, Damien. I imagine you're planning to model the designs that you're going to be working on?
Definitely. That is expected of whatever plans we move forward with.
Okay, so those models, we'll talk, but if you're going to have 3D models, and it might help with your collaboration, then we might have a place to put them so it'd be public. I assume you're planning for it to be open source?
Oh, yeah. We're spaces for everybody.
Okay, so we'll talk.
All right, sounds good.
We have a question at the back here.
Here, I'm going to. Is there another one?
Yeah, we'll set it up at the break.
Yeah, hi Damien, Charles Redley. I have questions, comments. I absolutely applaud this initiative. I'm 100% on board, count me in. Tomorrow afternoon I'm talking about the lunar elevator, and there's a lot of synergy here. A lot of the ideas you present I'm going to be expanding on. Had a couple of historical comments. You didn't mention the NASA Constellation program, so NASA has actually done work more recently than the 1990s.
Okay.
The Constellation program ran from about 2000 and it was canceled in 2010. And the main reason, it's kind of murky why it was canceled, but the information that I've got is it got canceled when the projected price tag hit $100 billion, and the White House said this is not happening. Okay. So it's all about the cost, it's all about the money.
Yeah.
Ever since Constellation was canceled, the moon has been a four-letter word in NASA. There is stealth moon work going on. There is a little bit of money being spent on lunar projects, but until at the White House level there's some kind of initiative and direction, everybody's scared to touch the moon, at least on NASA. But, you know, we can continue working on it, and I think we definitely should. And there's a void that needs to be filled. But there was also, as well, the other interesting development was a couple of years ago, the Next Gen team in Washington, D.C., they published a report which was actually funded by NASA saying that using commercial methods and companies like SpaceX, we could get that cost of a Constellation-type mission down by about a factor of 10. So a few talking points to consider.
Yeah, let's talk some more later. And these are the kind of ideas we need. This was a very quick micro-literature review, and the only large paper I found that had a lot of base designs in it was that one from the 90s, so I don't know what kind of products we got from that project that was between 2000 and 2010, but I'd be interested in finding out more. Thank you.
It's a little odd to me that you want to build a Starship on the surface of the moon. I mean, if you build it in orbit, you don't have to handle 1.6G loads while you're construction. You don't have to launch it. So your mass should be quite a bit smaller, and you can put larger things together. I mean, I can see all kinds of great reasons to have a settlement on the moon. Don't get me wrong, building a Starship doesn't really seem like a particularly good one of them.
You know what, why I put that there, yeah, go ahead, Andres.
So there's no one way to the stars also means there's no one way to build it. So unless you trade the entire operation of setting up shipyards on the moon versus shipyards in space, and you see what the sustainability of that kind of thing is. So if you build an orbit, for example, you're going to have to keep the station in orbit all the time. If you're going to be around the Earth, it's going to decay, so you're burning fuel continuously. Machinery, equipment, everything's going to be floating away. Of course, it's not hard if we just say so, right? But landing thing versus, we're not making a decision about which one is correct, versus landing something on the moon, where you can do all of the other things and have access to resources. But essentially, that's yet to be determined. You know, it's just something to trade against and have conversations about. But my personal opinion is that I'm hopeful that the scales will be lifted from our eyes, and we'll realize that the moon is full of resources. There'll be nickel, iron. There'll be all of the geology and the minerals that we would have otherwise mined from the Earth. We're going to find there, and I think it's like a Twinkie, you know, with a little bit of dust on top, and inside it's just going to be full of all these resources that we're accustomed to on the Earth. But again, that's something to trade against, right? So we figure out which works best.
But we can talk about that later, since Damien.
Hey.
Another question?
I like this idea a lot. I think in terms of where you build it, you know, you'd probably build it in orbit around the moon, which would be a lot lower gravity, where well and no atmosphere issue like around the Earth. But I think the biggest hurdle to overcome, and one that you should probably address very early, is how you're going to pay for it.
Yeah, definitely.
And that's, you know, I don't think it's going to be government funding. And what is the economic model that's going to get you there? What product can you produce that will pay when you have to ship it back to Earth where the market is, et cetera?
Yeah, let's discuss that more later. Thanks.
Hey, nice presentation. I'm going to talk a little bit tomorrow about why it might make sense to make some starships on the moon. But in the meantime, my question was, I enjoy working with young people, and is there a mechanism where I can get involved with a local chapter, or even maybe get a local chapter rolling out in Colorado?
Hallelujah. That's what we need. So yes, definitely.
Any other questions?
I was just going to ask real quickly, have you done any research with other nations with their lunar projects, and do you feel that there's a sense of being able to work together with these other nations with lunar projects, if you have studied these other lunar projects that are in place with other nations?
I didn't get the first part of that question, so let's talk later. The second question about getting other countries to participate in. Not too much, actually. So this is, you know, just a call to arms. People who are interested in studying that should bring it forward to the table and be part of the project. Yes, of course. Yep.
Any more questions? All right, we're going
Thank
to
you.
wrap up right now. Thank you, Damien Turchi. Yeah.